Assalamu alaikum everyone. Myself Sheikh Shaurian Nehal, ID 1260. Today we will discuss about priority scheduling. We have 4 members in our team, Himel and other 3, including myself. Now I will briefly explain what is priority scheduling. Priority scheduling is a method used in operating system to manage tasks or process based on priority. Each process is assigned a priority level and the CPU scheduling them for execution accordingly. Process with higher priority is crucial, while lower priority process wait for their turn. Now let's look at some key use of priority scheduling. Defining priority, this scheduling method assigns a priority level to every process. This helps to determine the order of execution based on importance. Resource allocation. Priority scheduling ensures that processes with higher priorities are uh, generated access to CPU and system reduced before those lower priorities. Efficiency and fairness. Finally, this scheduling aims to optimize resource utilization and maintain fairness by priority importance or time sensitive process. This ensures smooth and efficient operations in system. Uh, Now our next presenter will continue the presentation.
Assalamu alaikum, sir. I am MD Himel Ahmed Niloy. The last digit of my ID is 1284. Today I'll be presenting on two important concepts in the domain of operating system: priority scheduling and the comparison between static and dynamic scheduling. These concepts are fundamentally in understanding how processes are managed within a computer system, ensuring efficient execution and resource allocation. Priority scheduling plays a crucial role in ensuring the high priority tasks are given the necessary CPU time while managing system resources efficiency. Priority, se- pri- Priority scheduling is a CPU scheduling algorithm where each process is the system is assigned a priority value. The scheduling selects the process with the highest priority for execution. There are two types of priority scheduling: primitive and non-primitive. Primitive schedulings are a higher priority process can interrupt a lower priority process. Non-primitive scheduling is the process continues execution until it completes, even if the higher priority process arrives. Next slide. So now we'll be talking about static priority scheduling. Assigns fixed priorities to process at the start, which remains unchanged throughout execution. This is simple and predictable, but can lead to starvation of low priority tasks. Dynamic priority scheduling, on the other hand, allows priority to change during execution, usually through mechanism like, again, ensuring fairness and preventing starvation by increasing the priority of waiting process. In essence, static priority scheduling is straightforward but less flexible, while dynamic priority scheduling adapts the system's need, but it is most is more complex. Now I would like to call my next team member.
Hello everyone, I am Shovik Dhali. My ID is on59. Today I will discuss about preemptive and non-preemptive scheduling in simple terms. First, preemptive scheduling. Imagine you are doing a task, but your teacher suddenly asks you to stop and do something more urgent. That's how preemptive scheduling works. A higher priority process can interrupt a lower priority one. This method ensures important tasks get done quickly. Next, I'll talk about non-preemptive scheduling. This is like waiting in line. Once someone starts their turn, They finish before the next person starts. A process keeps the CPU until it completes. Even if something more urgent comes up, it simply is simple and easy to manage, but may delay important tasks. Next slide. Now I will explain three key algorithms used in priority scheduling. First, let's talk about shortest job first. This algorithm prioritizes process with the shortest execution time. It's like completing the smallest tasks fast to clear the workload quickly. Next is earliest deadline fast. Here priority is given to process with the earliest deadlines. This is common in deadline driven systems like video stream or transaction processing, where tasks must be completed on time. Lastly, we have rate monotonic scheduling. This algorithm is used in real-time systems and prioritizes tasks with higher execution rates. In other words, those that need to run more frequently. Thank you. Now my next teammate will talk about the next topic.
Assalamu alaikum. My name is Shahriar Shihan and my ID is 1888. Today I will talking about the shortage job first. Shortage job first SJF can be considered a special case of priority scheduling, where the priority of each process is determined by its burst time. In SJF, the shorter the burst time, the higher the priority. There are four processes. Process A, duration 2 unit. Process B, duration is 5 unit. In the process C, duration 1 unit. And the process D, duration is 3 unit. Next slide. Earliest deadline fast. Earliest deadline fast is a dynamic priority scheduling algorithm used priority in real-time system. It prioritizes process based on their absolute deadlines. The task with the earliest deadline is given the highest priority. EDF is widely used in systems where meeting deadline is critical. There are three processes: process A, B, and C. Process A deadline 10 unit, process B deadline 5 unit, and process C deadline is 15 unit. Now I call my next teammate.
Assalamualaikum everyone. My name is Mubirul Islam. My ID's last four digit is 1626. Today I will discuss on two topics: rate monitoring scheduling and practical consideration for priority scheduling. Rate monitoring scheduling. Rate monitoring scheduling is a widely used real-time scheduling algorithm for fixed priority primitive system. Below is an evaluation of RMS in terms of its key characteristics, advantage, and limitation. Key characteristics: fixed priority scheduling, primitive scheduling, deterministic behavior. Advantages: simplicity, optimal for fixed priority systems, and utilization. Limitation: utilization bound, no support for periodic or assumption and restrictions. Priority inversion. RMS is suitable for systems where tasks are periodic, independent, and RMS assumption. Deadlines are equal to task periods. Practical consideration for priority scheduling. Next slide. Priority scheduling, while conceptually straightforward, requires several practical considerations to ensure effective implementation and predictable behavior in real-time system. There are key practical considerations. Priority assignment, appropriate priority policy, task characteristics, handling priority inversion, task and system assumption, task periodicity, execution time estimation, resource sharing, real-time constraints, processor utilization, handling non-periodic tasks, fault tolerance and robustness, Implementation challenges, external interactions. Priority scheduling is a powerful technique, but its effectiveness depends on careful consideration of system requirements, task characteristics, and environmental constraints. Addressing these considerations ensures robust, predictable, and efficient system behavior. That's all about me. Thank you.